Hi, it is JIT UA Courses, and welcome to lesson number 14 of the .NET Developer series, in which we will cover the most relevant topics to becoming a .NET developer. So hit the subscribe button and bell to see new videos on our channel. Okay, let's go. In this lesson, we will learn about serialization and reflection. If this sounds interesting to you, don't hesitate and hit the like button. Serialization. Serialization is the process of converting an object into a stream of bytes for storage in memory, a database, or a file. The main purpose of serialization is to save the state of the object so that we can recreate it whenever we need it, and we can send the object to other applications using web services or other services. We remind you once again that the program is not magic. The program is interaction with information. All our class objects are also information, and we can save it for later use or pass it to another program. For this, we need serialization. It's like we have folding furniture from IKEA. We bought them and use them in our house, but if we don't need them yet or they take up too much space, we can disassemble them, put them back in the box and move them to the garage for the time being, or take them to friends, and they can fold them according to our instructions back in use. Similarly, serialization helps us store or exchange objects in our program. The following diagram illustrates the serialization process in C#. Generally, if we serialize an object into a stream of bytes, i.e. some sequence of memory, it will contain information about the specific type of the object, such as its version, assembly name, etc., along with the data. We can serialize objects using binary or XML serialization. In binary serialization, all members will be serialized and performance is better, but XML serialization will provide better code readability and more flexibility to share objects. It can also be JSON or other formats. If you want to serialize a specific object, such as a class, you need to apply the serializable attribute to it. If we don't want to serialize a certain field in our class, we need to apply the non-serialized attribute. Below is a simple example of serialize attributes in a class. We serialize the UserDetails class by adding a serializable attribute, except for the location field, so we added a non-serialized attribute. Deserialization. Deserialization is the reverse process of serialization, meaning that it converts a stream of bytes into an object. The main purpose of deserialization is to read a stream, again, just a sequence in memory, of bytes from a file, database, or memory, and we can turn it into an object. As discussed in the previous serialization topic, we can serialize objects using binary, XML, or JSON serialization. During the deserialization process, we need to use the same serialization pattern to convert the object into a stream of bytes. Deserialization example. Below is an example of deserializing a class that we serialized and saved to a file using binary serialization. We serialized the UserDetails class using binary serialization and saved everything to a file. After we use the same binary sequence format to deserialize object. That is, the sequence of bytes of the UserDetails class will be saved in the test file. Reflection. Reflection is used to obtain type information. It describes assemblies, modules, members, parameters, and other entities in managed code by examining their metadata. The system.reflection namespace will contain all classes that provide access to managed code metadata for type information. We can also use reflection to dynamically instantiate a type at runtime, bind a type to an existing object, or derive a type from an existing object and call its methods or access its fields and properties. If we define any attributes in our code, they can also be accessed via mapping. Again, C# code is executed in the CLR environment, and this environment manipulates not just our code as instructions, but also additional information about our code. And reflection gives us access to this information. It's like a code looking at itself from the outside. Of course, the first question that comes to mind is why this, because we wrote this code and we know what it contains, class names, constructors, types of arguments, etc. Yes, but sometimes we need the program to do certain things for any code. For example, a certain validation of parameters in all methods whose name contains the word validation. Whether to automatically fill the arguments of the constructor with a certain type, if the class of this type implements the controller interface, or the injectable attribute. Writing all this by hand means repeating the same code sometimes hundreds of times, and with the help of reflection we can generalize it because we do it as if not from the code, but from the outside from the environment. Overview of reflection. Below are important points that we should remember about reflection in C#. Reflection is useful for obtaining type information that describes assemblies, modules, elements, parameters, and other entities in managed code by examining their metadata. With reflection, we can dynamically instantiate a type at runtime, bind or derive a type from an existing object, and call its methods or access its fields and properties. It provides access to perform late binding and retrieve information about the types of methods created at runtime. Reflection is the process of detecting types during program execution. Each program contains a set of used classes, interfaces, as well as their methods, properties, and other building blocks that make up the program. And reflection allows you to determine all these constituent elements. That is, the main task of reflection is the study of types. The main functionality of reflection is concentrated in the system.reflection namespace. In it, we can distinguish the following main classes. Assembly represents an assembly and allows you to manipulate that assembly. Assembly name stores assembly information. Member info defines common functionality for event info, field info, method info, and property info classes. Event info stores event information. Field info stores information about a specific field of type. Method info stores information about a specific method. Property info stores information about a property. Constructor info representing a constructor. Module allows access to a specific module within an assembly. Parameter info stores method parameter information. These classes represent building blocks of type and application, methods, properties, etc. But to get information about the members of a type, we need to use the system.type class. The type class represents the type being studied, encapsulating all information about it. Its properties and methods can be used to retrieve this information. Some of its properties and methods are: FindMembers method returns an array of member-info objects of the given type. GetConstructors method returns all constructors of this type as a set of constructor-info objects. GetEvents method returns all events of this type as an array of event-info objects. GetFields method returns all fields of this type as an array of field-info objects. GetInterfaces method receives all interfaces implemented by this type in the form of an array of type objects. GetMembers method returns all members of a type as an array of member-info objects. GetMethods method retrieves all methods of a type as an array of method-info objects. GetProperties method gets all the properties as an array of property-info objects. NameProperty returns the name of the type. AssemblyProperty returns the name of the assembly where the type is defined. NamespaceProperty returns the name of the namespace where the type is defined. IsArrayProperty returns true if the type is an array. IsClassProperty returns true if the type represents a class. IsEnumProperty returns true if the type is an enumeration. IsInterfaceProperty returns true if the type represents an interface. Getting type. To manipulate a type and get all the information about it, we need to get the type first. This can be done in three ways: using the typeof operator, using the getType method of the object class, and using the static type.getType method. Obtaining a type via typeof. A person class is defined here with some functionality. And for getting its type information, we use the expression with typeof, obtaining the type using the getType method inherited from the object class. Unlike the previous example, here, to get a type, you need to create an object of the class. This is all for this lesson. Thanks for watching. Hope you enjoyed it. Don't forget to subscribe to the channel and hit the bell so as not to miss the following videos in the series. Feel free to leave a comment and like this video. You are also welcome to leave any questions in the comments section. I will be happy to answer them. And also I encourage you to help brave people in Ukraine to defend themselves in this horrible war. Please use the QR code or links in the description to visit charitable foundations that help Ukraine. Thanks. See you in the next videos.